Okay, so last time we studied the derivations of certain questions on radius and velocity. Now radius equals to n square h square upon 4 pi square m k z square. Now let us revise the velocity. mvr equal to nh upon 2 pi and electrostatic force k z square upon r square is equal to centrifugal force. Now from there r is cancelled. Now this can be written as mvv, and this r you brought here, this is called mvr, angular momentum, and that can be written as nh upon 2 pi. So put this value here, nh upon 2 pi. Okay, nh upon 2 pi. This nh will go in denominator and 2 pi will go here. So velocity equal to 2 pi, velocity equals to 2 pi k z square upon nh. I cannot remember, nobody can remember all these formulae, but you can derive easily. Okay, now let us calculate energy. See what happens now. An electron is revolving here, radius of the orbit is r. Now the concept of potential energy you must remember. You can use the knowledge of classical physics, that work done equal to force into displacement. Now work done equal to potential energy, and what potential energy is? This is electron, this is being attracted by this, but certain force is experienced by the electron in the outward direction, outward. So what happens? This is in the balanced stationary orbits. So force is centrifugal force, and this is balanced by electrostatic force. Put the value of force, that is electrostatic force, q1 q2 upon r square. What is q1? Z into e upon r square, and the distance is again, this d is r, so r cancelled. So kz square upon r, but the sign of this is negative. So q1 positive, q2 is negative, electron. So potential energy equal to minus kz square upon r. Okay, now you need the value of r, that's why I have written here. So n square h square upon 4 pi square monkey z square. Okay, so total energy possessed by electron while revolving in an orbit is kinetic energy plus potential energy. So total energy equals to half mv square plus potential energy is k q1 q2 upon r square, force into distance, displacement. So r cancel, kz square upon r minus k z into e upon r square upon r, minus plus minus. So total energy equals to half mv square minus kz square upon r. Remember this quantity. What is the value of mv square? Centrifugal force. Where is centrifugal force? Here, and its value is mv square by r. This centrifugal force is mv square by r. Now the centrifugal force is equal to electrostatic force kze square upon r square, ze into e. So q1 q2 ze into e upon r square is the force. q1 q2 q1 is ze into e, z square upon r square. Okay, now we need the value of this mv square. You can easily find out the value of mv square, and that is equal to kz square by r. kz square by r. So total energy equals to half. What is the value of mv square? mv square equal to kz square by r. Put the value here, kz square by r minus k z square by r. This quantity and this quantity are same. So minus one quantity plus half quantity equals to minus of half of that quantity. Suppose this is potato, this is also potato, so one potato and half potato, the answer must be half, but minus. So this is the total energy. This is the formula for total energy. What is potential energy? It is already written here. This is potential energy. What is potential energy? Okay. Potential energy equal to minus kz square by r. So total energy is minus. Potential energy is also minus. Now kinetic energy is half mv square r plus kz square by 2r. These are three expressions extensively used in all competitive examinations. The relation between total energy, potential energy, kinetic energy plus kz square by r. Kz square by 2r. Okay, so let us finish the expressions for this. Let us revise. Potential energy, kinetic energy and total energy. Every expression has kz square by r at least. Kz square by r, kz square by r, kz square by r, but potential energy has no digit here like this 2. So kz square by r minus. Now kz square by 2r, half of this, but in positive. Okay, in plus. Total energy equals to what? Equal to kinetic energy. Equals to kinetic energy. Let us see. Total energy equal to kinetic energy, but in negative. Half kz square by 2r minus. So these are the expressions. Let us calculate the formula for total energy. What is total energy there? Kz square by 2r. Kz square by 2r, and we in the earlier lecture calculated the value for r, and that was n square h square upon 4 pi square mkz square. Okay, so put the value here. 4 pi square, what is r? 4 pi n square h square, n square h square upon 4 pi square mkz square. This is the value for r. Put this value here. Okay, let us put total energy equals to kz square upon 2, and this is 1 upon r. Kz square upon 2r. So what is r? N square h square. N square h square upon 4 pi square mkz square. Mkz square. Done. Now 2 2s are 4. Okay, total energy. This is the final expression. 2 2s are 4. So 2 pi square k square m. Okay, m. Now z e to the power 4 and k finish z e to the power 4. 4 pi cancel, m k, done. N square h square. Again let us see. K square. Okay, done. E to the power 4. Okay, z and z square. Yes, z square. 2 pi square m. Okay, n square h square. Done. So total energy equals to z square by n square. Remember, this total energy is negative, so it must be negative, minus, let us calculate this, 13.6 into z square by n square. Electron volt. Now in joule, what you are going to do? 1.6 into 10 to the power minus 19. So multiply this 13.6 by 1.6. You will get the answer in joule per atom. Joule per atom. But this expression is good. Next one. Okay, let us revise this. Radius increases, velocity decreases, and energy. What happens? Radius is directly proportional to n square by z. Velocity is directly proportional to z by n. Now energy is, here you are made puzzled. Here it is negative, so total energy is directly proportional to n square and not the z square because of this sign. So directly proportional to n square and inversely proportional to z square. So since the sign is negative, you reverse this expression when you talk about ratios and comparisons. So as we go on increasing the orbits, energy increases. Let us see how the energy increases. Let us see. So we are going to compare the energies of different levels of hydrogen atom first, and then we'll go for helium atom. This is hydrogen atom first orbit, second, third and fourth and fifth. Forget about the distance, separation increases. Okay, 1, 2, 3, 4, enough. So what is the energy here? 13.6 into minus 13.6 into z square by n square. What is z square for hydrogen? 1. Let us write the total energy minus 13.6 into z square by n square electron volt. So what is the energy in the first orbit of hydrogen atom? And that is equal to n square by z square by n square. So minus 13.6. Minus 13.6. What is the energy in the second orbit? Minus 13.6 into z square by n square. So that is equal to 13.6 divided by 4, and that is 3.4. So minus 3.4 electron volt. And the third orbit, it is divided by 13.6 divided by 9, square of 3, because z square by 3 square of 3, 9. So that is minus 1.51. In the fourth orbit, minus 13.6 in the fourth orbit, minus 13.6 into z square by 4, square of 4 is 16, and that is equal to 0.85 minus 0.85, around 0.8485. Okay, see what happens here. Now if I supply some energy, what happens? This negative energy means least amount of energy. Most negative means least amount of energy. We must supply some energy here, then only the electron will jump, and this will cause emission spectrum. Absorption spectrum. Absorption spectrum. If the electron jumps from this orbit to this orbit, the difference between these two energies will be emitted. Here the energy is absorbed because the electron is going from first orbit to second orbit. So change in energy would be E2 minus E1. The sixth postulate of Bohr. Bohr's sixth postulate says that when electron jumps from higher to lower level, energy is emitted, and that will be the difference of the energies in the two orbits. And if it goes from lower to higher level, energy must be supplied, energy must be given, and given means always positive. Let us see how. E2, this is minus 3.4 electron volt, minus, what is the value of E1? Minus 13.6 electron volt, that is equal to minus 3.4 plus 13.6, and that will be plus 10.2 electron volt. And this is the question that is frequently asked. What is the energy required to go from first orbit to second? That is plus 10.2 electron volt. Maximum amount of energy is required here. Sir, from third orbit to fourth orbit, what is the amount of energy required? Let us calculate. Energy required to move the electron from third orbit to fourth orbit is E final minus E initial. Let us calculate this. What is the energy in the fourth orbit? And that is equal to minus 13.6 into z square, since hydrogen is there, 1 square 1, divided by fourth, and we know the energy. There is no need to calculate again. We have calculated the energy in the fourth orbit is minus 0.85, minus, again write this, E3 is what? Minus 1.51. and that will be equal to minus 0.85, minus 0.85 minus a minus plus 1.51. So the difference would be 1.50 rough 0.85. This 4, 10, 5. This 14, 10, 6. Minus or plus, plus. So plus 0.65, this is the difference between the energies of two levels, and that difference must be supplied, therefore it is positive. If the electron jumps from here, it will be minus 0.6, means energy will be released. Now the question is, E2 minus E1 is always greater than E3 minus E4 or E4 minus E3. E2 minus E1, E3 minus E2. So the difference in the energies of the orbits closer to the nucleus is always more than the difference of the energies in the orbit which are away from the nucleus. This is very important question asked in different examinations. Let us compare the energy levels of hydrogen with that of helium. Now the question asks, sometimes which level of hydrogen and helium atom will have same amount of energy? This is the question. Which level of hydrogen and which level of helium? Suppose n equal to 1, so here n equal to 3. They may have same energy? No. So n equal to 4, they may have same energy. N equal to 2. Let us calculate. Again revise the question. Which levels of hydrogen and which level of helium will have the same amount of energy? This is the question. Okay. So E of hydrogen equal to E of helium minus 13.6 n square. Which levels? Suppose this is 1. Now the question should be modified. The first level of hydrogen atom has this energy x. In which orbit the energy of helium will be equivalent to x? This is the question. So minus 13.6 z square by n square. We have been given the question, in the first orbit the energy is x. This is the energy in the first orbit, and that is going to be equal. Now this is z. Now helium, it is 2, square of 2. We have been asked to find out the number of orbit. So now this is n square. We don't know the number of orbit. Cancel. So n square equals to 2 square, square of 2. So n equal to 2. The energy in the first orbit of hydrogen atom is equivalent to the energy of electron in the second orbit of helium. Okay. So this is the answer. Let us match this. Minus 13.6 into z square by n square. What is z square? 2 for helium. And this is 2. N square is 2 square. Cancel. So in the second orbit of helium, the energy will be equivalent to the energy of the first orbit of hydrogen, n square, z square by n square. Z is 1. And 1. So 13.6 in the first orbit of hydrogen, 13.6 in the second orbit of helium. Okay. So this is one variety. One more question, and this is the last question. This is the last question because my time is up. The last minute is over. Okay, let me start with this. If the energy is minus 1.51, okay, minus 3.4 is the energy in an orbit of hydrogen. Calculate the number of orbit. Calculate the number of orbit. This is the first question. There are so many questions that can be asked on this. So many variations. Minus 13.6. So energy equals to, again, energy is given in the orbit, but orbit is not given. We have been asked the question to find out the number of orbit. Minus 13.6 into z square by n square. Now for hydrogen it is 1. Now for hydrogen, it is 1. Energy is given minus 3.4 minus 13.6 into z square by n square. Cancel, cancel. No. It is 3.4, sorry. Let me write it again. Energy equal to minus 3.4 minus 13.6 into z square by n square, minus cancel. N square equals to 13.6 divided by 3.4. 3 4s are 12, so it is 4. N square equal to 4. N square equal to 2 square, so n equal to 2. This is the second orbit. This is the answer. Now you have been asked, what is the velocity here? What is the velocity here? In the same question, what is the velocity? In the same question, the velocity is asked, what is the radius here? What is the time period of revolution in the second orbit? What is the frequency in the second orbit? What is the angular momentum is in the second orbit? So let us calculate this and the lecture will be over. Let us come to velocity. 2.18 into 10 to the power 6 z by n. Okay. So velocity equal to 2.18 into 10 to the power 6. What is that? Hydrogen 1. N equal to 2. So it is 2 ones are 2. So around 1 into 10 to the power 6. Around 1.08, 1.09 into 10 to the power 6 meter per second. Okay. This is the next. Second question finished. What was the question? Energy is minus 3.4 in hydrogen atom, z equal to 1. What is n? Calculated. What is v? Done. What is radius? Now, what is radius? 0.529 into 10 to the power minus 10 if it is asked in meter per second. So 0.529 n square by z. What is n square? We have calculated 2. Now, radius equal to 0.529 into 10 to the power minus 10 meter per second, otherwise it is in angstrom. N square is what? 2 square, 4 by z, hydrogen 1. So half of 4 is 2. So 2 into 10 to the power minus 10 meter per meter. But if we are asked in angstrom, then 2 angstrom. So 2 into 10 to the power minus 10 meter. Next, we have been asked, what is the time taken by the electron in the second orbit to complete one revolution? So what is velocity? 2 pi into circumference, this is 2 pi r upon time. So what is time? 2 pi r by velocity. Okay, so 2 pi, what is r? 0.529, and we have calculated this. 2 into 10 to the power minus 10. What is velocity? Again we have calculated this, around 10 to the power 6. Okay, done. 2 2s are 4, 4 pi. 4 pi. That is equal to 12, around 13, 14 4s are. 14 4s are. 0.5. So 13, 4 2s are 12, 12.5 into 10 to the power minus 16. Minus 16. This small time is required. So what is time? 1.25 into 10 to the power minus 15 seconds. Now what is frequency? Just opposite of this, 1 upon time. So 1 upon 12.5 into 10 to the power minus 16 will go in the numerator, it will become plus 16. Now write it 14 by, this is 100, 14, 12 2s are 25 and 25 4s are 100. So 12 6s are, 12 7s are, 12 adds are 100, 12.5 adds are 100. So 8 into 10 to the power 14 around. So what is frequency? 8 into 10 to the power 14 cycles per second, that is called hertz. So this is the frequency in the second orbit. In 1 second the electron will revolve 10 to the power 14 times. Now what is MVR? Angular momentum. You can also calculate what is linear momentum. So MV, what is the mass of electron? 9.1 into 10 to the power minus 31. What is velocity? What is velocity? We have calculated 1 into 10 to the power 6, and that will be 9 into 10 to the power, this is 25. This is kilogram meter per second. Okay, linear momentum, but we have not been asked linear momentum. No problem. Go for angular momentum. Just multiply it with 0.529 or 2 into 10 to the power minus 10. So what is angular momentum? Linear into radius. L equal to what is P? 9 into 10 to the power minus 25. And what is radius? That radius equal to 2 into 10 to the power minus 10. Here it is needed in meter. Okay, done. 18 into 10 to the power minus 35. 1.8 into 10 to the power minus 34. You can go for so many expressions. As we study in physics, like EMI, electromagnetic induction, Bohr magneton, so many formulae we go, and you put the values here of radius, velocity, momentum, time, frequency. So this chapter is very important. Bohr's postulates and the application of Bohr's model, these are very important. Nobody is going to ask you in the postulates of Bohr's model. Nobody is going to ask. And if anybody is going to ask, you know very well. Okay, the last question MVR, done. Okay, thank you very much. Now the lecture is over. We will study next lecture tomorrow.